Alright guys, it is Wednesday and I'll be back tomorrow, so if you want to come see me during flex or before school or lunch, come see me if you're totally confused, but I'll be in class tomorrow. So anyway, let's get started. So today is a little bit different because we're going to talk about this thing called a recursive formula. Recursive formulas, they aren't very useful, to be honest. However, they describe what's going on. So first of all, here's an example. It says A1 is 5. Well, that's easy. Okay, let's write down 5. But it says then, find the next 5 terms. So let's see. Well, this a to the n minus 1 power, let's see. What does that mean? Well, let's go ahead and do this bit by bit. So I've got my first term, a1. a1 is 5. So if I want to make a2, now, that means in this case, n is 2. To make a2, I'll write that down, to make a2, to make the second term, n equals 2. All right, so if that's the case, let's take a look. a2, yeah, I want to make a2, so n is 2, and that's going to equal, let's see, it's going to equal a to the n minus 1, so it's going to equal a to the 2 minus 1 plus 4. Okay, again, this is kind of weird. Let me go through it slowly, okay? That's how a recursive formula works. You have the first term, a1 is going to be 5. Then to make the second term, a2, n would be 2. So a2 is equal to a to the 2 minus 1 plus 4. Okay, well, let's keep going with that. That means a2 is equal to, well, a to the 2 minus 1, well, that's just 1, isn't it? So that means a1 plus 4. Oh, wait a minute, we know what a1 is. a1 is 5. So a2 is just simply going to be 5 plus 4, which is going to be 9, okay? So a2 is 9. Okay, now, if I want to make a3, okay, so I'm going to say, okay, I want to make a3. So a3 is going to be the third term, right? So if I make a3, in this case, n has to equal 3, okay? So a3, so a is 3, so I'm going to go, okay, to make it, I'm going to use my formula. I'm going to go, all right, a3 is made by going a to the 3 minus 1 power plus 4, okay? Well, that's a2, right? So a3 is equal to, well, that's a2 plus 4. Well, a2 is 9, isn't it? So a3 is going to be 9 plus 4, which is going to be 13. Okay, let's see what's going on. So really, what does this a to the n minus 1 mean? It just means it's the previous term. It's the term you just wrote down. This a to the n minus 1 means if you want to make the next term, you go and use the term you just used. It's the previous term. So if you want to make the fourth term, if you want to make the fourth term, you go to the third term and add 4. Well, that's the third term. Okay, so if you want to make the fourth term, you go to the third term and add 4. So 13 plus 4, well, that's 17. If you want to make the fifth term, you're going to go to the fourth term, that's the 17, and add 4. 17 plus 4 is 21. And that's how you make a recursive formula, okay? It doesn't help us a lot in the fact if we want to make the 100th term, but it describes what's going on. What are we really doing? We're taking a term and adding 4 to it. Taking a term and add 4 to it. So let's take a look at example 2. Same kind of thing. Okay, we know A1. We know A1 is, slide up, A1 is 2. So if I want to make the second term, I'll take 3 times the first term. Okay, 3 times the first term. The first term is 2, so 3 times the first term is going to be, 3 times 2 is 6. Okay, keep with me. If I want to make the third term, I'll take 3 times the second term, which is 6. 3 times 6 is 18. If I want to make the fourth term, so if I want to make a of 4, I'll take 3 times the third term, right? That's the third term, a of 3, that's the third term. So 3 times 18 is 54. If I want to make the fifth term, I go 3 times a to the 5 minus 1 power, right? 5 minus 1, which is the fourth term. So 3 times the fourth term. Well, that is the fourth term, so it's 3 times 54. 3 times 54, and I get 162. So again, it describes what's going on. It tells us take the first term and multiply it by 3. Okay? All right, now, let's take a look at example 3. Find the first 25 terms. Oh my goodness, for real? I don't want to find the first 25 terms. That'd take forever, okay? But what we can do instead is just know that we're always going to add 4. All right, so I can do that. I'm going to add 4. I'm just going to go, okay, 5. I'm going to add 4, right? Add 4 and I get 9. I'm going to add 4 and I get 13, right? And then if I want to find that 25th term, that's what I really meant, find the 25th term. If I want to find that 25th term, I could keep making it, keep making it, keep making it, keep making it. But if I want to find the 25th term, by the way, I am changing directions. I meant to put that there, find the 25th term. Then I got to go back to what we learned before, okay? I know this thing's arithmetic. So if I want to find the 25th term, I can make it. I keep adding 5. I keep adding 5, keep adding 5. But if I want to find the 25th term, then the fastest way is to use a formula that we had before. We could go a of 25 equals n times a1 plus, oh, wrong formula, my bad. A of 25 is equal to a1, which is 5, plus n, which is going to be my 25 minus 1 times d, which is 4. There we go. I got to fix this. That's what happens when you're in Hawaii and not here to fix things. Okay, so 5 plus 24 times 4, and I get an answer of 101. So the 25th term is 101, okay? So let's go back to this. First of all, I meant to say find the 25th term. Forgive me. I know the first term, and I know I'm going to add 4, add 4, add 4, add 4. So I could do that. I could go and keep adding 4 for 25 times, and I get to 101. Or I can go, wait a minute, there's a formula, a of n, that we learned last week, a1 plus n minus 1 times d. So we're going to use our explicit formula to find, okay? Now the same thing as example 4. Let's find the 25th term. Find 25th term. Okay, to do that, let's see. We know that we're going to start with 2, and we're going to multiply by 3, right? 2 times 3 is 6. We're going to multiply by 3, and we're going to get 18. Multiply by 3 and get 54. Multiply by 3 and get 162. This is exactly what we did up here. Now, if I want to find the 25th term, I keep multiplying, 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 multiplying. Or I can remember that there's a formula. Yeah, there's a of 25 is equal to a1 times r to the n minus 1 power. So in this case, a25 is equal to a1, which is 2. My multiplier is 3, isn't it? Times 3 to the 25 minus 1 power. Okay? So we'll just use our calculator. I'm going to go 2 parentheses. Don't multiply those. Let's see if I can show that. I can't. I can show you 2 times 3 to the power of 24, right? Boom. Oh, that's a big number. That's a E. So it's going to be about a 5.64 times 10 to the 11th power, okay? Scientific notation, that's my E, okay? Big number, okay? So finding the 25th term, doing it step by step by step would take us forever. Let's use our formula, okay? All right, so let's go to our journals. And if you need to pause it, go ahead and pause it. We're going to go to our journals, okay? All right, so if you're going to use our journals, we need to go straight to page 218, okay? Let's go to page 218. Let's do this again. So page 218. And if you need to pause to get your journals, page 218, okay? All right, let's do both of these, okay? So first of all, number 1, we know we start with 2. It's our first term. Now, this means if we're going to make the second term, we'll take the first term and add 5. 7. To make the third term, we'll take the second term, that's this one, plus 5. 12. To make the next term, to make the fourth term, and it's 4, we'll take the third term, that's 12, and add 5. To make the fifth term, and it's 5, we'll take the fourth term, that's 17, add 5. To make the sixth term, if n is 6, a of 6, so I want a of 6, I'll take the fifth term, which is 22, and add 5, which makes this 27. Okay, that's all you got to do. So this a to the n minus 1 is just the previous term. If you want to make the 8th term, you take the 7th term. If you want to make the 11th term, you take the 10th term. If you want to take the 50th term, you take the 49th term. That's all it means. Okay, so now how do you make a rule? Well, to make a rule, you have to start with this. You must start with A1 because you have to know where to start. A1 is 9. So then, what's going on? Looks to me as if I'm adding 3, adding 3, adding 3, adding 3. So to make a formula, I also have to say a of n equals. So to make any term, we always take the previous term, a to the n minus 1. We always take the term right before it, and we add 3. So if we want to make the 1, 2, 3, 4, 5, 6th term, we take the 5th term and add 3, and so forth, and so on. Okay, let's look at number 4. Okay, number 4. 50, 20. I bet we're probably dividing by, let's see, 20 divided by 50, 0.4. So I think we're multiplying by 0.4 each time. So let's double check it. 50 times 0.4, yep. Times 0.4, yep. Times 0.4, yep. So what I'm doing, you can see on my calculator, I'm just multiplying everything by 0.4, 0.4, 0.4, and it's working. So what are we doing? So in order to make a recursive rule, you have to know where you're going to start. You must write the first term. You must go A1 equals, because you have to know where you're going to start. To do a recursive formula, you start with the very first term, which is 50. Okay, but then to make the next term, any term, you take the term before it, a minus 1, you take the term before it, and in this case we're going to multiply times 0.4. Okay, that's about it for recursive formulas, okay? Alright, so I'm going to stop the recording.